Hello everyone, and today we're going to talk about displacement and time graphs. But we're kind of going to talk about more about like the difference. So first of all, let's talk about displacement time graph. So and something how it would look like would be so and then So, and let's say we have a person, right? So this guy, he walks 2 meters. By the way, on the top we have the displacement, and over here is the time in seconds, and the displacement is in meters. So let's say the guy walks 2 meters and it takes him 5 seconds. We would do it over here, for example. So let's say 5 would be here, 2 would be here. We'll do something like this, and then we get this type of idea, right? Now let's say the guy, he walks backwards this time, and he walks backwards 7 meters, and it takes him 10 seconds. This time it would go like this, so 10 seconds would be here, and let's say so 2 minus 7 is minus 5, so let's say minus 5 was here. The result would be something like this. So, and this is how the displacement works. However, now let's discuss oh, let's discuss the distance time graph. And plus minus, it would look like a normal graph. I mean, so wait. ده بلين يعني خدته. It would look something like imagine everything without these, right? It would be like this, like just this one. So let's have the same situation, like the guy walks, over here we have time, and over here we have distance. So here 2 seconds, and then at 2, so it'll be here, and this time it's not gonna be minus 7, it's gonna be plus 7. So let's say we had a 9 somewhere here, 9, right? I mean, instead we can just do 4. Instead of, like, it's the same situation, but with 4 he goes 4, so it should be like kind of minus 4, but instead, and it takes him, let's say 4 seconds also, we would do just the same, like we'll just continue the line, but most likely in a different color. So, and just make sure that we know that they're two different stuff. And the difference between these two over here, for example, we can know how much meters is a second. So it's going to be, again, rise over run, like the gradient. So gradient equals speed in here. However, here the gradient equals velocity because it can be negative. And I want to ask a question to ChatGPT. Okay, sorry. Oh, you're nearly there. Still interested in lifting service? No. Let's go. Where's ChatGPT? There it is. Hey there. Right now, I'm like revising displacement and time graphs, and basically I looked at displacement time graph and distant time graph, and the difference is basically like for the distance time graph the gradient is equal to speed. However, under displacement time graph, gradient is equal to velocity. However, from what I remember, velocity can't be negative, or can you just explain that in more detail?
Yeah. So velocity can definitely be negative.
Oh.
That negative, yeah, negative just means direction. So like speed is just how fast you're going, but velocity is speed with a direction attached.
Aha. So that's why it's velocity, because you see we go over here, we can only go up. Over here, I mean, we could probably go down too. No, we couldn't, because each time the person's gonna move, it's still gonna go up. Yeah, it can't go like zigzag. Over here, it can go a zigzag. So that's the difference. So that's everything. Goodbye.